And the next one that I'd like to demonstrate is actually a very new stent. So we've not started using this, but as of next month, it'll be approved, hopefully, in Singapore for use. There have been some use in Europe and some studies as well elsewhere. It is a stent, after all, and a stent is a scaffold that you can open up. In the past, all we had were balloons. We moved on to stents, and now we're getting better and better stents. Unfortunately, even with the best stents that have existed up till now, adverse events remain high with the current technology. We have adverse events accruing at a rate of 2 to 3% per year, and unfortunately, with no plateau. And this is what these slides actually show you, the graphs. So what we're trying to do is change that. So this is another JAMA article. In essence, adverse events which occur after the first year at a rate approximately 2 to 3% per year may be attributed to strut fractures, loss of vessel compliance. I mentioned arteries being elastic. You put a stent in, you cage it. Loss of vessel compliance, vasomotion, motion of it, and the capability for vascular adaptive remodeling. Okay, so other things such as coverage of side branches and new blockages occur as a result. So this is what it looks like. And if you look here to the right-hand side, what you see is a metallic stent. It looks like it's pulsing with the artery opening and closing if you look at it here. And that's because after 6 months, there is a little joint like this that's got a polymer on top of it that dissolves, then allows it to move. So this is what happens immediately post-procedure inside the stent. It dissolves and goes away 6 months post-procedure. Then it becomes flexible after it's had an opportunity to heal. When you stent something, there's an opportunity for a layer of tissue to form on the inside of the stents. And when that happens, that's when it's healed. But unfortunately, it's caged. So with this technology, it allows it to move. This is what the stent looks like. These are those hinges, if you will, within the stent. There's a lot of stent design, and years have been spent on different types of stent design, and these guys have come up with something very significant and very game-changing, because the stent is the same size in terms of the thinness of the struts as other stents, as the best-in-class stents, but they have some unique components to them, such as these little couplers here. Okay. And in doing so, what we have is that it can maintain the ability for positive adaptive remodeling, can restore vessel function, and allows return towards a baseline angulation. And you see this in the subsequent slides that we have as well. So this is intravascular ultrasound. I mentioned this a few times because what you do is you pass a wire through and you do an ultrasound looking out. Many of you will have seen this, with ultrasounds of the heart, ultrasounds of the fetus. This is a vessel moving. This is what the vessel looks like when you put a stent in. It doesn't move, it doesn't pulse the same way as this guy over here. But after the uncoupling of the hinge, this fella is moving a lot more like this one over here. And by doing that, we reduce the shear forces and stresses within the artery, allowing it to function as it should, allowing it to function as nature intended it to function. This is another technology that we tend to use in our procedures, which is optical coherence tomography, OCT, using light rays. And these are actually the stent struts with an acoustic shadow behind them. And after the uncoupling, this allows this to move this way. Absolutely beautiful. So I'm looking forward to using these stents. What we've been showing you up till now have been stuff that we've been using. This is something that's coming and we're planning on using. And this is why it makes so much difference as well, because this is the angle of the artery. You stent it, you straighten the whole thing out, and you change what nature had intended. But when these things become more flexible as a result of the dissolving of that polymer, you get a regain of the original angle. You don't put as much shear forces on the artery, and theoretically, one should get less blockages. This last few slides explains how we do this. So it maintains ability for positive adaptive remodeling, restores vessel function, compliance, pulsatility, and dilatation, and allows a return towards a baseline angulation. Generally, same size as normal stents, and therefore similar sort of outcomes. I always love this slide. This This actually shows you how interventional cardiology has grown over the last 50 years. We started with ballooning. Unfortunately, 50% of those used to reblock, and sometimes the arteries used to get damaged. We had to put stents in. 30% of the bare metal initial first generation stents used to reblock, up to 30 to 50% sometimes too. Drug-eluting stents came on board a decade later, and these are all in decade jumps, by the way. The first generation ones weren't as good, but subsequently from 10 to 20% reblockage rates over your lifetime sometimes, it has dropped down to less than 10%. And then we had the absorbable stents, and they were all the rage until a few years ago because they found that the reblockage rates were higher. I still believe in this technology. There's always a problem with technology being rolled out too quickly sometimes. There's new studies being done that show very good results with dissolvable stents. But until then, we have to go with the metallic drug-eluting stents. And that's where the bioadaptor or the DynamX comes in. And this is the new generation of it at all. And if you look at the progression, you find that in the 1980s, we had this, 1990s, 2000s, 2010, and 2020s, this is what's coming through. Before the 1980s, everybody needed to have bypass surgery if you had a block. The numbers of bypass surgeries are dropping because the technology for the minimally invasive procedures have increased significantly and have actually been growing in leaps and bounds. The 2020s onwards, we'll be starting to use devices such as this. This is a video of how this works for the DynamX. And after that, we'll probably be ending this to go into the Q&A. But I have to thank once again the vendors for sharing some of these slides with us and the companies and giving us permission to use them. This is what a block is like, and when it's stented, what happens to the artery. If you look at this segment here, you'll find that this is pulsating, and above there is pulsating, but this whole area is caged and unable to move. That is not the way nature intended things to be. So what happens with this is you have these hinges here, where there's a polymer sat on top. The bioresorbable stents used a similar sort of polymer, and this company actually has its own bioresorbable stents as well. These polymers dissolve over time, allowing that hinge to move and allowing the artery to move, not perfectly perhaps, but a little bit more the way nature had intended it to be, and therefore reducing the risk of abnormal shear forces within that stented segment and potentially reducing the risk for blockages getting worse over time and the need for re-intervention as well. But what you see here is drug being eluted, the little particles, and then after that, healing with a new layer, neointima inside. Initially, it is rigid and doesn't move, but at 6 months, when all these things dissolve and move away, what you then get is a flexible stent. A flexible stent that moves with the artery. And here you see the old technology or the older technology where it doesn't move. That area pulsates, but the whole thing pulsates here instead. So I'm hoping that these few technologies I've shared with you have been of some interest. There's a lot more we could go through. The bioabsorbable stents, we've been using quite a lot of that. I've been using extensive use of drug-eluting balloons, just balloons that elute drug without putting a cage in it. All these technologies combined reduce the amount of metal we have to put in for patients. And in doing so, improving outcomes for them as well.